In Classic, today we are meeting on revision term 1. We just want to make sure that we prepare for end of term. I just have got some question paper that we are going to work with today, which is from Free State Province. So it is actually just a complete term 1 paper. So please note that we are doing geography. It is grade 11. And note again that if we're going to write this paper, you should take at least 1 hour. And one other thing is, I say that this is in this case we are going to do the paper and also discuss answers that can also be able to answer those questions, suitable or best suitable answers for those questions. So please kindly follow and let's revise together. Let's ensure that we are ready. This paper is a typical of our paper that we are going to write end of this term, and it is the latest one. This is a last year paper. So let's do it together right now without wasting any time. We just go through it. I'm sure that instructions for grade 11, you always know that when going to exam, you always check instructions. I'm not going to read them through with you, but anyway, you must read instructions anytime when you go to exam. So we are supposed to answer this question. Question 1, it's about the atmosphere, and we are given various options that are supposed to be chosen from. And here we are given the atmosphere and high altitude. It's given here atmosphere, high altitude, and we are given low altitude, and we are given this is the earth. We are given the earth there, and then we are given incoming solar radiation, incoming solar radiation here that is given. So the question is saying, given this, it is about the orientation, it is about the incoming solar energy. So now towards the earth. So now incoming solar energy that reaches the earth's surface is called dash. The incoming energy that reaches the earth, the incoming solar energy that reaches the earth's surface is called dash. I'm sure that you must understand that when the solar energy when the solar energy is released and it reaches the earth, it is defined as insolation. Insolation is what we call incoming solar energy. When it reaches the earth, it is called insolation. Energy loss, we can talk about energy loss. In this case, this is not energy loss, it's incoming, and it is actually called it's called insolation. Absorption is when heat energy is taken into an object. It has got, when an object has got a capacity to actually take in energy as it comes in through it. And of course, high temperature, it is not that what you call high temperature. You're talking about just the temperature of the sun. So the answer is insolation. And then the amount of insolation that reaches the atmosphere depends on dash. The amount of insolation that reaches the atmosphere, it depends with latitude. Latitude as the position on the globe. The latitude defines or affects the amount of energy, which is also affected because of the position or the distance from the sun. So we have got latitudes as to say the lines that runs across the earth, across the globe there. So what happens is that if we look at if we look at low latitude, there is direct solar energy, or there is direct incoming solar energy. It is direct incoming insolation at low altitude, at low latitude, at low latitude. What happens is the orientation of the sun is quite direct, and therefore, as we are saying, at equator, high temperatures or temperatures, they are so high at equator here. At equator, temperatures are very high. which is 0 degrees. At equator there, we have got high temperatures. This is 0 degrees. Temperatures are high. Temperatures are just high there. What happens is that the solar energy is hitting the earth on a greater surface, unlike when it reaches or when it hits the earth at at high altitude, at high latitudes. So the high latitudes, the orientation or the anchor is low here. The anchor tends to be low when we talk about high latitude. Anchor is low, anchor is small, and then it is hitting at a direct, it is hitting at a direct position. Because of that, it has got the exposed anchor, or the anchor is big. So that is why you tend to see that on the lines that are showing insolation at the central point here at low altitude, at low latitudes there, what happens is that it actually identifies that there is a direct exposure of solar energy which hits the earth at high angle, or the position or the part of the earth exposed to the sun is big. So as that, what happens is we tend to have more, or we tend to have the highest amount of incoming heat reaching the atmosphere, depending on low altitude or affected by latitudes, unlike high latitudes. So the Coriolis force is about the deflection of the earth as it rotates, and that cannot affect the incoming solar radiation. Wind is actually causing the movement of what? Of energy. And then the further one moves from the equator, the more insolation will what it is. When we move far, when the distance that we move, as we increase distance from the equator, the amount of energy decreases as we move from the equator. What happens here is that equator, as I said here, the distance as it increases, as the distance increases from equator here, the more we go down, we are saying solar energy or incoming insolation, the energy decreases. It decreases with the distance from the equator. It decreases as we move away. It tends to decrease as we move away from the equator. The amount of energy decreases. It actually identifies that the insolation, it decreases with the distance from the equator. It decreases, which is the answer is what is A. It's A, it decreases. Here we say the answer is B. So please note that as we move away from the equator, the energy or the insolation, it decreases as we move away from the equator. The Earth receives more energy than it needs at the equator, as the Earth receives more energy than it needs at the equator, as energy surplus. Surplus is excess. Energy surplus, we are saying this is what is energy surplus. That means to say it's excess. Surplus is excess. Energy distribution is not like what it needs. Energy distribution is the movement of heat energy because of just the movement of wind, or because of the movement of air. Energy deficit is lack. When we say less, if we say it receives less energy, this is less energy than it needs. That's when we call deficit. When we say balance, it means it is equal to what is needed and what is received. It is equals to what is received and what is needed. That is when we say it is what? It is balanced. So please note that the answer is A. when it has got, when there is more energy than the earth, than what is needed by the earth, we say it is excess, it is more, it is excess, therefore it is what? It is a surplus, as to say is above what is actually expected. So please note that. Next question, it gives us the seasons occurs as a result of dash. Seasons are caused because of the revolution. The revolution is actually the one that causes what? Revolution is the one that causes seasons. Seasons occur as a result of revolution. Revolution, as to say, when the earth moves, the revolution causes seasons. And then insolation, we said, is the energy. Rotation, it actually causes, it is the one that causes the day and night. So, but revolution, it actually causes seasons to occur. Ocean currency, it is actually affecting also the energy balance. The ocean currency also affect the the energy balance. A sketch A illustrates dash in the southern hemisphere with the days being dashed and the night at the equator. In sketch that is above, what is being identified is that it illustrates the summer solstice. It illustrates the summer solstice and also uh, in the southern hemisphere with the days being longer than the nights. It is when the days are longer than the night at the equator, which is what? Which is 2 and 3. It is 2 and 3, which are correct. Therefore, we say that the answer is what? The answer is C. What happens is that we are saying it identifies on sketch A, it identifies that in the southern hemisphere we do have it identifies in the southern hemisphere that we have got summer solstice, which have got days that are longer than the night. In sketch A, it identifies solstice, and with the it identifies the summer solstice, and with the nights that are being longer than with the days that are being longer than the night, which tends to tell you that the answer is what? Is C. Dash represent mid-autumn days that fall on the 21st of March, when there is equal length of days and night. Where we talk about, you see this diagram, if you can check also on the notes, it has been explained enough that I'm sure that enough information has been explained, but for the sake of progress in this case, what I want you to see is that the representation of mid-autumn days that falls on 21st of March, when there is equal length of days and night, it is actually shown when we look at when we look at sketch when we look at sketch B. Sketch B identifies where we say there is equal length of day and night, which is what we are saying equinox. Equinox identifies situations when days and nights are equally the same, the length is equally the same. So it is shown when we look at sketch B. This diagram, it's just a matter of understanding it. It is given that we have got this is June, and then we say sun solstice or sun equinox, and then what happens is that HB is when we have got equal nights and days, which is actually a diagram that is deep, that is always known when it comes to this representation. It is not to say you calculate, but this diagram just needs to be known that on the 21st of March, when there is equal length of day and night, it must be known that according to this diagram, it occurs when we are at what? When we are at B. So the 7 marks, you were able to take them. And then we are given statements and choose the appropriate. We are given statements here, which we are supposed to choose the appropriate words in brackets to make the statement true. And then this is the eighth. We are given the different cells that are given here: the equatorial low pressure belt, the subtropical high pressure belt, the sub low pressure belt, polar winds, and we have got all these identified, the different pressure belts that are identified on the earth as we look on the globe. So the also types of winds. I was saying again, certain times you would find that the question that comes with types of winds that are found at different pressure belts. Identify the winds that are developing or that are found. Types of winds at different pressure belts that are there. So I'm sure that before we even go to answer this question, I have already also previously given you the latitudes. You need also to know the latitudes. You need to know the latitudes that are there to say at 65 to 90 or 65 and above latitudes, we have got the polar winds, and then we also have the subpolar low pressure belt, which is between 55 to 60. 55 to 60, I'm saying you need to know the type of pressure belt that is found there. The subtropical high pressure belt, which is between 25 to 30. So you shall find out that even in map work, you are given these pressure belts, and then you need to be able to label them. So for you to make it easy for you, you must always understand that the equatorial low pressure belt, it is always in the 5 degrees latitudes positions. And then as we move to the south and north, if we are talking about movement to the south, we are saying we talk about the easterly winds, which are also being subtended by subtropical high pressure belt, which ranges or which is within 25 to 35, 25 to 35, 25 to 35 degrees latitudes, which are also below them having the westerly winds, which results in what? In these other types of winds, and the polar winds, which we can go to 90 degrees, and then we talk about high pressure belt that are found there. So please, what I'm saying is these pressure belts and the latitudes are supposed to be known as what as the types of winds. So we have got three questions that comes here. We have got to know the latitude, the type of wind, and also the type. We are saying the latitude and also the pressure belt, and also understand the pressure belt that is found within different latitudes that are there, pressure belt. So I'm saying we do have three questions that comes here. We have got three questions that comes in this case, so that whenever we are going to find these in the exam, let's not just revise the question that we have now, but be able to understand any other relative questions that comes from this information infographic that is given here. So this is what it is. And then I'm saying, let's go to the questions that comes there. We are given the subpolar low pressure is created by dash of the air movement. The subpolar low pressure, low pressure, it is created by dash subpolar low pressure, subpolar low pressure, as you can see. we are saying this is the one which is between 55. We are talking about a 55 to 65 degrees latitude. It is created by what? It is created by convergence of wind. Which winds are converging? We are saying it is formed as a result of convergence. It is formed as a result of convergence. What is converging here? As you can see, we have got the westerlies and the polar winds that are moving towards each other almost at 55. We are saying, let's just say between 55 and 65 degrees latitudes. Convergence of what? Of the westerlies. Convergence of westerlies and what? And polar winds. As they converge, we are saying it results in the formation. Uh, it is actually created by the convergence of the polar winds and the westerlies. They actually converge and results in what? In subpolar low pressure that you are seeing there. And again, even equatorial low pressure, it is also, as you can see there is also convergence of winds that are there. But subtropical high pressure, it is divergence. As you can see, we have got the air move diverging, meaning to say that they move in opposite direction. When we say diverge, please note that it is what? It is convergence that is causing it is convergence that is causing uh, the subpolar low pressure. It is created by convergence. As I said, it is convergence of this air mass and also that other air mass. When they move towards each other, we do have the subpolar low pressure belt. But if you look at subpolar high pressure, it is what? It is divergence. As you can see, the subpolar the subtropical high pressure, it is what? It is divergence. It is divergence which forms that. So that must be known. And then ITCZ is associated with dash pressure belt. ITCZ, if you can see ITCZ, it is actually associated. ITCZ is associated with equatorial low pressure. It is always known that the ITCZ is associated in the tropical convergence zone. It is associated with equatorial low pressure belt. Equatorial low pressure belt, which we say that the position of ITCZ, it is found closer to the equator there. So it is associated with equatorial low pressure belt. That is why we talk about the movement of ITCZ either up or down, which is caused because of the movement or the changes in seasons. So now we are saying that the revolution of the earth causes or directly affects the position of the ITCZ. So it is associated with equatorial low pressure. It is associated with equatorial low pressure belt. That is the one that actually is associated with international tropical we are saying tropical convergence zone, the national tropical convergence zone, which we are saying there is convergence of air masses that are there, which we have seen also that we have got the convergence of air mass. We are saying we have got the air mass which are moving towards each other, whereby we have got the low pressure, equatorial low pressure belt that is formed there, which is also resulting in this. We say that the ITCZ, which is found within this region of the equator, the number three, subsiding air, warming air causes a pressure belt of high pressure cells called dash. The subsidence, it is causing the subsiding warming air. Subsiding, we are saying this is also sometimes defined as sinking. it is sinking, it is falling. When air is sinking, after air rises, it cools down until it cannot further rise, and then it starts to fall down. When it is falling down, it is warming up. It causes the temperature to go up. So when air masses are falling, they are actually associated with increasing in temperature. When they are rising, we are saying rising air masses causes temperature to cool down. Sinking air masses causes temperatures to warm up. Temperatures, they actually increase with what? Temperatures, basically in this case, temperatures goes up or temperature increases. Temperature increases. If we are talking about sinking air masses, temperature increases. When we talk about sinking air masses, so when air masses are subsiding or they are sinking or they are falling, what happens is that temperature increases, and therefore we talk about these with regards to these are associated with subtropical, uh, they are associated with subtropical uh, high pressure cells. They are associated with subtropical high pressure cells. Sinking air masses are associated with subtropical high pressure cells. These is to also, we are saying they are associated with sinking or subsiding air masses. Subsiding air masses are associated with we are saying they are associated with subtropical high pressure cells. That is what happens with when air masses, we are saying this is the pressure belt that is associated with that subtropical high pressure. Subtropical high pressure is the one that is actually associated with subsiding air masses. As you can see also on the globe there, we are saying it is subtropical high pressure belt. Dash dash blow from the subtropical regions to the temperate regions. If we look also, the air mass that also moves from the subtropical to temperate regions, we are saying you should see that we are saying if you can look at this, it is quite supposed to be known that subtropical to temperate regions, we have got westerly winds. Subtropical to temperate regions, these are the winds, or we are saying the westerlies. The westerlies are associated, or these are air masses that are the air masses that blow from the subtropical regions to temperate regions is the westerlies. Westerlies are the ones that also that are associated or that blow the westerlies. They blow from the subtropical regions to the temperate regions. I'm saying it is the what? It is the westerlies. We are saying these blow from subtropical to temperate. That we can see. We are saying this is a matter of just going to the going on the infographic, and then you are able to see it through to say what are they saying from subtropical high pressure. We are saying from 35 degrees latitudes and above, we have got westerly winds which are moving into the subpolar pressure belts, which we are saying they are the westerly winds that we can see there. It is the westerly winds that goes into the temperate regions. Therefore, the answer is westerly winds, number 1.4, 1.24. And then we have got also a continuation, which is identifying geotrophic flow, which I also tried to exhaust and explain quite a lot in the question paper. I mean, in during the lecture or during the course of the term. So the air at one at a pressure at the air at one high pressure at a high pressure area moves towards the low pressure area because of the movement of air mass from high pressure to low pressure, a movement of air mass, we are saying it moves from high pressure to low pressure. What causes that? It is caused because of what? It is actually caused as a result of the pressure gradient. Pressure gradient always identifies or causes air movement. Pressure gradient identifies or causes air movement. If you can refer again, like I said, from the lessons that we have gone through, pressure gradient, it is the one that affects or causes air movement. The difference in air mass or in pressure gradient, it actually causes what? The movement of air. To say high pressure to low pressure, we have got pressure gradient force, which is, we are saying the pressure gradient force. I have already also defined and showed this, where we were also defining and illustrating the concept of or the movement of air mass. As you can see, we are saying from high pressure to low pressure, you see that we are saying this is 20 hectopascals, and then it moves from 20, the air is moving from here to there, it moves from 15 to 10. This is the movement that we are talking about. It is the movement which we are seeing, it is from high. We are saying the low is this one. So high to low, it is high to low if you compare also from that point to other point. So this is high pressure, as you can see. And then we are saying the direction of movement is shown by this one. Direction of movement of air, movement of wind, direction of wind movement. It is given there that that's the direction of wind movement, which we can see that it is moving from high pressure. It is moving from our high pressure there, high pressure, and then the pressure decreases as we move towards up there. So we are saying we have got low pressure as we go up. So we are saying pressure gradient affects air movement. And then number 6, it is wind deflects or change direction because of Coriolis force. Coriolis force, the deflection of wind either to the right or to the left because of the rotation or because of the movement of the earth. So Coriolis force defines or causes deflection. It deflects, it causes air to be moved either to the right or to the left based on the hemisphere in which the movement is taking place. I already also explained that in southern hemisphere and in northern hemisphere, how is the deflection taking place? So now we are saying it is wind is deflected, it is changed the direction because of the Coriolis force, which actually operates in terms of the contrast which occurs when the earth deflect, when the earth rotates and air is moving, air is caused to bounce or to change direction. So when the wind reaches 5, both forces are balanced. The wind is now being when it reaches 5, we are saying when the wind reaches 5, both forces are balanced. The wind is now is now blowing. It is blowing. If the forces are balanced, if the wind reaches 5, as you can see, we are saying as the wind reaches 5, if it reaches 5, what happens is when it reaches 5, both forces are balanced. The wind is now blowing parallel to the isobars. The wind blows parallel to the isobars. It blows parallel. It is actually we are saying this one. It is at 5. The wind it blows parallel. It blows parallel to the what? To the isobars. It blows parallel to the isobars. The wind blows parallel as to say that it will move, like we are saying it will move parallel as to say just like lying below the isobars or above the isobars. So what you need to understand is that we are talking about this as what this is what you call the Coriolis force, which is abbreviated as what? As CF. CF represent Coriolis force. So the wind blows when the forces are balanced, it blows parallel to the isobars. It blows parallel to the isobars if the wind or if the forces are balanced now. The direction of wind in the sketch above represent conditions in, we are saying the deflection, as I was saying, you can see, we are saying the direction of wind in the sketch, it shows a movement that is taking place. It is taking place. What do we see? What do we saw? What can we say? We are saying it is anti-clockwise. So what happens there when wind deflects anti-clockwise in southern hemisphere? I mean anti-clockwise. We are saying that it is uh, it is blowing in what? In southern hemisphere. We are looking at saying that the movement which you can see here, wind movement, it is moving in an anti-clockwise direction. You are seeing, why do we say that it is anti-clockwise circulation that we can see here? The anti-clockwise circulation identifies that we are having air movement that is taking place in our southern hemisphere. And then the clockwise, it is when it circulates or it moves in what? In we say in northern hemisphere. So in southern hemisphere, we say that wind moves in an anti-clockwise direction. It moves in an anti-clockwise direction, which we are saying it is from the high pressure to the low pressure. I'm sure this, I've already also illustrated that to say air moves from high pressure to low pressure. So as it is, this is a high pressure cell, so it tends to move from the center in an anti-clockwise direction. So which is what southern hemisphere, this is a southern hemisphere condition that we are seeing. However, we can have the northern hemisphere, which can also be, we are saying this is our high pressure again. So air moves in a clockwise motion. It moves in a clockwise direction, which is also showing northern hemisphere. So we are saying our our movement is from high to low pressure, which is actually showing, it is showing anti-clockwise, I mean clockwise and also anti-clockwise. So as you can see, this is southern hemisphere, and this is the other one is what? Is northern hemisphere, which we can see we are saying from high to low, from high to low. And then what happens is that it identifies an air circulation that is taking place in northern and southern hemisphere. I'm sure these must be known also, as we are going to continuously uh, look at them and do them until grade 12. We are always going to talk about these air movements class. We are always going to talk about them. So H is here. So we have got our law at the outside. This is exactly what you see there on the arrows that I'm drawing here. The arrows are showing high at the center and low outward. So we are saying our A, it moves from the center going outward. Go and check also on the notes that I had given you. The notes that I have given you, they identify these air circulations that we are talking about. That is in southern hemisphere and also that is in northern hemisphere, as you can see in these diagrams. So please follow up and try to make sense of these, because you shall use them forever and ever more. We have got the phone winds. which is devil's wind or devil's breath or the red wind. That is also there. So these are of other names for the Santa Ana winds that are notorious in Southern California. They belong to the katabatic phone winds like the Bora. They originate from high that forms over the Great Basin, typically forming in the winter months as temperatures are high in summer, tend to counteract a high heat flow. So we have got the Santa winds often hit the coastal area with the gale strong winds with speeds of over 100 kilometers per hour and that are not uncommon, and 150 kilometers are also possible. The air is very low, the air is very warm to hot and stands in a stark contrast to the otherwise rather subdued temperatures in winter and also California current temperatures rise abruptly uh, when the Santa winds arrive and the air is warmer than the desert inland due to sinking movement. This also this air is also very dry and relative humidity can drop below 10%. So we are given the infographic again here, and then the questions are saying we are given the infographic. So uh, what happens here? I'll just bring it again. I'll just check it and bring it again there with the paper. It also just omitted. But most of the times you are asked to understand that what is phone winds. The question which are there is explain phone winds, define phone winds, and then when do they the seasons that they occur, and also why the wind is warmer and dry. Why is the windward side is usually wet or rainy? The impact of phone winds. So what is happening here is that we need to understand, define phone winds, define what is phone wind, define phone winds. Phone winds. These are just, we say phone winds are just winds. These are dry, warm, dry winds that descend on the windward slopes of mountains. I'm sure if you can also check in my presentation, you can also identify that we explained quite a lot and even diagrams explaining phone winds, which are warm, dry winds. Warm, dry winds that we see actually descending, that descends. They descend as to say they fall uh, on the leeward slope of a mountain. They descend on the leeward slope of a mountain. That is phone winds. And then one other question is that you need to be able to explain. The other question that comes there is to say why the winds is warmer and dry. Why are these winds warm and dry? Why are they warm and dry? Why are phone winds warm and dry? What happens is that I want you to understand is as the air descends on the leeward side of the mountain, it warms up rapidly at the, at the dry adiabatic lapse rate. The air warms up as it descends from the mountain. The air warms up as it descends. As it descends from a mountain, it warms up as it descends from the mountain. And then what happens that it warms up as it returns from the mountain rapidly. There is a rapid warming up. This is at a dry adiabatic lapse rate. Dry adiabatic lapse rate. Dry adiabatic lapse rate, which is quite a lot of times abbreviated as what? As DAO. Dry adiabatic lapse rate. Because what happens, because now there is little moisture in the air and a drop in relative humidity also takes place, which we can also to say very dry, and relative humidity is also dropping. So what happens is because the air has got little moisture, because the air has very little moisture, the air, it has very little moisture. And then what happens is that as it has got little moisture, what happens again is that it actually defines what low relative humidity. It has, we say that, and relative humidity has dropped below 10%, and low relative humidity, or we can say, or low relative humidity. That is one thing that happens there. I'm saying, explain why phone winds are warm and dry. This is because of the subsidence. We said that when the air masses are falling, they warm up. So the question is, why are they warm and dry? Why are the winds, or why these air masses are warm and dry? They warm up because of the descending from the mountain at dry adiabatic lapse rate. We are saying what happens is that the temperature is increasing with what? With a decrease in height. So the dry adiabatic lapse rate causes them to warm up. So therefore the air has got very little moisture, or a very low, or a very low relative humidity, because of the subsidence from the mountain, as we have said. So that is one quick question that comes when we are there. And then, why the windward side is usually wet or rain? Explain why the windward side is wet or rain. Explain. Explain why the windward side is wet, or why does it have rain? Why is it wet or rain? So I'm sure that again, you should be able to understand that it is because of the moist air that is rising up on the windward slope. We have got warm moist air that rises from the windward slope. Warm moist air rises from the windward slope. Warm moist air rises from the windward slope. So now it cools as it rises. I'm sure that you remember that warm moist air as it rises, it cools as it rises. And then what happens is that as it rises, it cools down, and then condensation occurs. Then there will be rain on the windward side. It cools as it rises, causing condensation. I'm sure you remember condensation cloud formation resulting in cloud formation. Clouds formation. Therefore, when clouds are formed, resulting in cloud formation, hence rain, then we can have rain or snow. Rain or snow is actually is on the windward slope. Rain or snow can be found on the windward slope. So what happens here, class, is that when we look at this, the direction from which the warm moist air is rising, we call that a windward side. And then from where it is falling, it is the what? Is the leeward side. We are saying the direction from which the warm moist air is rising. We have got our warm moist air that rises this side. And then what happens is that this is our windward side, this side. This is our windward slope or windward side. And then this side is called the leeward. So what we are supposed to understand when it comes to these questions is that we have got condensation, where we have got clouds that form here, and these clouds will result in what? In rainfall. We have got rainfall on this side because of condensation that occurs from warm moist air that is rising. We have got warm moist air that rises this side. Warm moist air rises on the windward side, and then it results in rainfall. But here now, what happens is that the air that we are seeing on the other side of the slope, which is on the leeward side, it is descending air masses. These air masses are what? This is descending air. So when the air is descending, what we have said is that there is dry adiabatic lapse rate that takes place on this side. The dry adiabatic lapse rate occurs on that side, which is, we are saying the air is what? The air or the wind which we are finding, or which we tend to find on this side. This is warm, dry air. It is actually dry. It is dry air that we find this side. This is warm moist air. And then what happens is there is no rain this side on the leeward slope. We have no rain this side. No rain forms on the leeward side. We do have rain we have got rain on the other side. We have got rain on this side. Rain occurs on the other side. On the windward side, we do have rain on this side. So that is basically what the question is all about. It wants you to understand the leeward and the windward side, which is caused because of the variation in types of air masses that are associated with each of the sides that we are looking at, which at the same time we are saying these are foehn winds. Foehn winds, winds that are descending from mountain tops, and therefore they warm up as they fall, resulting in what? Resulting in no rainfall or clear skies, which at the end of the day are gonna cause just some strong winds, gusty, dry winds that are at the end of the day experienced in such places. Question 4, we are given the role of oceans in climate control in Africa. The role of climate ocean, we can talk about ocean currency. I have already sometimes also given a lecture on the issues to do with ocean currents in terms of the issues to do with ocean currency. But before we go there, there was a question lastly which also needs to be understood, that you need to know the impact of foehn winds on nature, environment, and management strategies as the last question that was supposed to be answered on impact of foehn winds. It was answered again, impact of foehn winds on environment. What is the impact of foehn winds on the environment? And then we also talk about management strategies. Management strategies in terms of managing those winds. Management strategies. Management strategies. I want you to know to say the impact here. We need to understand that we talk about drought conditions. The impact, it has to do with drought. The foehn winds, we do have drought conditions that are caused because of this. We talk about drying of vegetation. Drying of vegetation, it occurs. We talk about drying of vegetation because there's no water, there's no rain. We talk about promotion of rapid spread of forest fires, which we talk about veld fires. They also form, veld fires also form the veld fires. We also have them happening or taking place there. And then we talk about they may also cause avalanches and floods, which we can say the avalanches and floods can also be seen taking place, as to say, melting of glacier places. So, flooding of coastal places can also take place. Flooding of coastal places can also be another problem that is caused because of melting of glacier, which we can talk about there. That can also, it has to be taken note of. And then in terms of management strategies, this has to do with all other methods that can reduce the impact of these conditions that we have talked about. We have got educating public in terms of potential impact of these fires. We can talk about early warning systems must be put in place. Early warning systems. Early warning systems can also be very important for people to note that we might have such conditions or such kind of dangerous weather conditions that might arise. We talk about rising awareness about the importance of conserving natural resources, that people can take preventative actions that can also cause collective effort to reduce the impact of these winds. We talk about planting dense forests along the perimeters of susceptible areas. which can also help to protect the soil and the wildlife in those places, ecosystems, preservation of natural habitats, which can also safeguard the animals and plants and from the destructive foreign winds that we are talking about. This can also, we talk about planting windbreaks that can be done to reduce the direct impact of foreign winds on the environment. So please, what you need to understand is that we talk about preserving forests and wetlands and other natural areas. They are basically there to reduce the impact of foreign winds and also promote rainfall. Because remember, we are saying the problem that we are experiencing or that is likely to be experienced in this area is that of what it is a problem to do with uh, runaway fires that we are talking about and also low rainfall. So we are having, or we need to talk about strategies that can increase possibilities of rainfall and also conserving the natural wetlands that are already in place. So now we can just want to go and talk about question 1.4, which is ocean currency influences the weather of the coastal areas due to evaporation from the oceans and the winds blowing from the sea to the land carrying moisture. I have been saying that when air moves from the oceans to the land, we call that onshore winds. Onshore, they are more moist, they are warm and moist. They result in possible chances of rainfall. They are the ones that also cools the land. So we also have moisture that also comes in with them. We talk about mist and fog that are forming as a result of onshore winds. So now we want to look at city maximum temperature and minimum temperature. Maximum temperature in Durban is 28 and then the minimum is 20. We have got Cape Town 20 and 14 minimum. So the questions that we have are just here to say that weather conditions or weather outlook for Thursday, 19 December 2024. So we are given that we are given wind, we are given the different weather conditions that are given on this regard. So the questions that are there says we have got Indian Ocean, Atlantic Ocean, and so forth and so forth. So now define general temperature range. Define the temperature range. When we are talking about this, what it means is that it is we are looking at the difference between the high temperature of a day and the low temperatures of the night. Differences between high temperatures of the day and low temperatures of the night. That is what we call, we are saying, that is what we call the general temperature range. We are saying the differences between high temperatures of the day and low temperatures of the night. According to the infographic, which city has the smallest general temperature range and what is the range? Here, you are just saying, as you can see, you are just saying the high temperatures of the day and the low temperatures of the night. So you are only going to what? To work it out. Subtract the high from the low. 28 minus 20 minus 20 minus 28. If we work for Durban, we are saying Durban range is 28 minus 20, we have got what? We have got what is it? 8. And then we are saying 20 minus 25 minus 14. We have got minus 14 there. We have got 11. So the question is asking which one has got the low temperature range, according which is the smallest. We want the smallest. The smallest is what? Is Durban. Durban class 28 minus 20, which is equals to 8 degrees Celsius. 28 minus 8 minus 20 is 8 degrees Celsius. The one for Cape Town is 11, which is high. So identify the ocean current A and B, which influence the city, the climate of South Africa. Identify the oceans A and the ocean current A and B, which influence the climate of South Africa. This I had also given it before, that if we say A and B, the ocean current A, if you see A here, what happens? It is called the code Benguela currency. We have got the code Benguela currency at A. Code Benguela currency, which we find at A there. And then B, from the Indian Ocean, we have got the warm August. So that is to say A is it is actually the code Benguela currency. And then B, it is the warm August. These are the different currencies that we have. The code Benguela currency, and which I'm sure that you always know that when we are looking from the South Atlantic Ocean is the code Benguela currency, and then from the Indian Ocean is the warm August currents that are there. And then question next. The next question is saying, what do we call winds? What do we call winds that blow from the ocean towards the land? It is given in the context. We say the winds that blow from the oceans, from the oceans to the land, we call them onshore. It's called onshore winds. They are called onshore winds. These are called onshore winds. And then the next question is saying, explain why ocean current A is responsible for cold and dry west coastal conditions. Why A is we say the winds that are, if we say A here, it is, we are saying the winds that we are saying the cold Benguela currents. The cold Benguela currents is A here, which are from the South Atlantic Ocean. So what happens is that we just need to explain that the wind that are originating from, we are talking about the code Benguela currency. That is what the question wants us to talk about. These air masses, what happens with them is that we need to understand that the air the air above the cold ocean currents is cold. The air above the air above the cold ocean currents, the cold ocean current, the ocean currency, it is cold, and prevailing wind, and we have got prevailing wind. Prevailing wind blows this cold air towards the what? Towards the land. Prevailing winds blows. It blows this air towards the land. It is towards the land, which I want you to understand that decreasing the temperatures of the coastal regions. Causing temperatures of coastal regions to decrease. So what happens is that when this air blows, we are saying these are called ocean currents, which actually prevails, and then they blow towards the land, which actually causes the temperatures of coastal region to decrease. So now, what happens is that places, uh, places they flow past them, their temperatures can also decrease. So the cold Benguela ocean currents cause the temperatures of places on the west coast. The cold Benguela currency, the cold Benguela currency that we need to understand here is that uh, it causes temperatures of places on the west coast. Cause temperatures of places on the west coast. That is one thing that you need to understand. The air above the ocean current was the what? The water vapor, which is just little. So places washed by cold Benguela currents are drier in any case. That is one other reason. Air that is above the cold ocean currency, they naturally hold little moisture. They actually hold little moisture. So places that the cold Benguela current passes, they are naturally dry. The places are naturally dry because the air mass that moves towards or that moves through the places there, yet it just have the capacity to hold little moisture. So at the same time, what happens there is that it actually causes the places to be dry because the air mass is just cold and cannot be able to contain more moisture in it. The next question is saying, account for warm temperatures and high rainfall in Durban. Account for warm temperatures and high rainfall. Account for we are saying account for warm temperatures and high rainfall in Durban. How does it influence ocean currents? Be identified there. So what we need to understand is that if you look in that this we need to talk about things to do with the air above the warm ocean currents is warm and prevailing winds blow this warm air uh, towards the land, rising the temperatures of the places they blow past, and then the warm August currents raises the temperature of places of the east coast of South Africa, and then we have got the air above the warm ocean currents holds more water vapor and therefore it has got more chances of bringing rainfall in Durban. That is one thing that we should understand there. Air above warm ocean currents. Air above warm ocean currents is just warm, and we need to understand that prevailing winds, the prevailing winds that blow there the prevailing winds blow this warm air towards the land. This warm air towards the land. So now, what happens, therefore, it rises the temperatures of the places that they pass through and increases temperatures of the places that they pass through. Places that they pass through, they tend to have high temperatures because the warm air that moves through them is also warm. So we are just saying, as they move through those places, they actually tend to what? To increase the temperatures thereof. So that is one reason that is causing this situation. And then we also need to understand that the warm August current raises the temperatures of places on the east coast. The warm increases temperatures on the east coast And then finally, we can also need to understand that we also need to say that the last point that I can put here is that the warm air holds it holds more water vapor and brings rain in Durban. Warm air holds more water vapor and has more chances of bringing rain in Durban. That's basically what you need to understand in terms of why do we tend to have uh, why do we have a high rainfall in Durban is because of the influence of the ocean current B, which we are talking about, the warm August wind, which are generally warm, and then the warm air from there are very possible to cause chances of rainfall in these places. That is one thing that we need to take note of. And then lastly, the last question here, it is just showing the synoptic weather map, and we need to understand that what season is shown on the weather map. What season is shown on the weather map? It's a synoptic weather map, and we need to know the season which is on the weather map. What season can that be? I also answered questions about the weather map previously. The synoptic weather map that when given synoptic weather map, you should be able to answer questions that also follows to say in which season can we say this weather map was given. So if you are given here, what causes us to say which season can it be? We use cloud cover. Cloud cover is used to identify seasons also. Cloud cover can be used to identify seasons, and also the prevalence of the cold front and the position of it. So now, what season can this be? This can be winter. This can be winter, as we can see from this map here. This can be winter. I'm saying we are looking at cloud cover. Check the cloud cover that is given all over the map. It's all clear skies. We are seeing clear skies all over. The cloud cover that is given there is clear skies all over, as you can see here. All these are showing what? Are showing cloud cover that you can see there. So now, what happens is support your answer. It is clear skies on the east and interior of the what? Of the country. Reasons are presence of clear skies. Presence of clear skies on the east and interior of the country. Clear skies on the east and interior of the country. East interior of the country. The cloud cover, the sky is very clear. And then we have got also the presence of, if you can look on the map again, we have got the cold front that is there. We are seeing cold front. We are seeing cold front there. The cold front that we can see there, the cold front, which also presence of the cold front in the interior of the country. Presence of the cold front in the interior of this country also indicates that it's winter. Presence of cold front in the interior of the country. Presence of the cold front in the interior of the country identifies that we are in what? We are in winter. And then the next question is saying, determine the isobaric interval on the synoptic weather map, we are saying the interval of the isobars. This we can just see that we are saying from one isobar to the next, we have got 1012, 1008, 1004, 1000 going down like that. So we are saying the interval is the difference between one isobar to the next. So we can say this is 1012. It is 1012 minus 1008. 1012 minus 1080. That is the isobaric interval, which is we say 4 hectopascals. That is 4 hectopascals. That is how you get that 4 hectopascals. You can even also say 1008 minus 1004. You will see that is 4. And then name the high pressure system on the west of South Africa. On the west of South Africa, we always need to understand that we have got South Atlantic high pressure. We say on the west, we always have South Atlantic high pressure. South Atlantic high pressure is always found on the west of South Africa. South Atlantic high pressure is the one that we find there. And then explain how the high pressure system identified affects the weather in South Africa. How does it? It brings cold and dry wind weather conditions. It is more like what we just explained now. It brings cold and dry weather condition. Cold and dry weather conditions. It brings cold and dry weather conditions in South Africa. And then compare the wind strength between A to E and also G to F respect to the spacing of isobars. So if we can look at them, AE, and we say the difference between this one is well spaced. If you can see, it is well spaced. And then if you look at this one, they are closely packed. That is how we define their differences. So what happens is that when we see the one that is GF, which actually shows that strong winds or fast winds, wind speed because of the steep gradient that is showing there. The steep gradient closely packed, it shows steep. It shows steep gradient, this one. It shows steep gradient, and then we tend to have a gentle gradient. Gentle gradient is shown on the other side. So compare the two. So what we are saying is that in this one, we need to see that OE is DE, DE, DE actually it shows weak winds, identifies is equals to weak, it is equals to weak winds or a low wind speed. It can be low wind speed. Why do we say that? It is low wind speed, which is because of the gentle gradient shown by the spacing of the bars. Because of the gentle gradient, and then we are saying GF, it actually shows strong fast wind speed, or we can say strong wind. strong winds. Why do we say that there is? Because of the steep gradient. The steep gradient identified by what? By closely packed isobars. We are saying it is the isobars that are closely packed. So we can just want you to see that when we are looking at this GF, the isobars are closely packed. The isobars are closely packed. And then comparing to this is the isobars we are talking about. Closely packed isobars, steep gradient. Steep gradient because the isobars are what? Close to each other. That's what happens there. However, if we are talking about these ones, they are quite spaced. On the other one, they are quite spaced there. They are quite spaced, which can also show that this is a gentle gradient. The spacing of the isobars identifies that this distance, the spacing of the isobars identifies that we can have a gentle gradient, unlike on the other side. Uh, Unlike if we can compare them, let me put them where they can go, where they must go straight. We say if we look at these ones, we are saying on DE, they are quite spaced. They are quite spaced. The distance between the isobars identifies that this is a gentle gradient versus the other one that we are saying GF. So we can just finally finish the last question. The last question, it says, describe the weather conditions experienced in Durban. The weather conditions that are experienced in Durban. It is just more or less the same question that we have answered now. The weather conditions that are experienced in Durban. In Durban, we tend to have, Durban has got air temperature. Durban, we can talk about dew point Durban in temp. We have to look at the diagram there. Durban, we are given here. We are given that the air temperature is 35 degrees, and then the dew point temperature is 3 degrees there. We are saying also the cloud cover is clear skies. Wind direction is 10 knots. It's actually given there. So what I'm just saying is we are just interpreting the synoptic weather station that is given here. So Durban, we have got air temperature, which is 35 degrees Celsius, and then dew point temperature, 3 degrees Celsius. We also clear skies. Clear skies are also shown there. We have got 10 wind and wind speed, 10 knots. We also have wind direction is also given as to say that it is actually southwesterly wind direction. And then finally, we say no chances of precipitation. There are no chances of precipitation in Durban. These conditions are just visible on the synoptic weather map. I'm saying you are just reading the synoptic station that is given there. Dew point temperature 3 degrees, clear skies and wind 10 knots, which you are seeing. All those are given. These are shown. Durban, we are saying we are interpreting Durban year class. These are the readings that we are looking at. These are the readings. The southwesterly direction of the wind direction, the southwesterly wind direction, the wind speed, the cloud cover, and also no rainfall chances that are shown. So we are looking at Durban, considering that zone in there. That is where we are talking about. Durban is shown there. This is shown as to say that's Durban, which is given there. So class, thank you very much for your time. And I trust that I believe and expect you to pass all your term one tests that are coming soon. Have a good and great revision session. Please keep subscribing, liking, sharing, and also joining membership for us to be able to do more work for you. Thank you.